Calculus BC, we are looking at an amazing lesson today that will help us immensely with limits. You might notice that we haven't had many limits in our class up to this point. From now on, you're going to see that this new method is going to help us solve and help us out in almost every limit problem we're going to encounter. It's L'Hopital's rule, and L'Hopital's rule, you must meet the conditions to use it. So very important for that. Suppose f and g are differentiable on an open x interval from a to b, containing some x value c, except possibly at c itself. And if you take this limit as x approaches c of f of x over g of x, if you have an indeterminate form, 0 over 0, or infinity over infinity, and up on the top, I'm going to say we may have a plus infinity over a negative infinity, or a negative infinity over a positive infinity, or even both of those being negative. As long as a numerator and denominator are going to either a positive or a negative infinity, that means you may use L'Hopital's rule. But here's something that you must also know. I'm going to put a big star here. Never write this indeterminate form. Never write 0 over 0 or infinity over infinity, either one of them. You can listen to people on the College Board say if you do that, they're going to mark you down. So be careful. That's truly, even in their AP videos, they'll write 0 over 0, and then they'll say, well, look, this isn't a real number, and don't write it. You can see on a video, a guy will cross it out. But that's really what's happening. A numerator is going to 0, denominator is going to 0. Numerator is going to a sign of infinity. The denominator is. If you're meeting those conditions, then you can do something amazing. You can say that you're going to take the derivative of the numerator, f goes to f prime, the derivative of the denominator, that goes to g prime, work this limit out, and if that arrives at a real value, if you can evaluate that limit, that's going to be your answer. Wow, let's see this in action and see what's going to happen. So take a look at example 1. Now, this is so very, very, very important. You're going to need to know when you're doing these limits, you must always check if you can use L'Hopital's rule. I know you see a fraction here, and we're going to write the limit as x goes to 0 just of the top. The limit is x goes to 0 of sine of x. Well, I hope you know from the unit circle, the sine of 0 is 0. Down below, look at this. The limit is x goes to 0 of 2x. Well, that would be very close to 2 times 0. That's 0 over 0. You must check these two things, because if you do not, they're going to mark you down on an AP free response. You won't get full credit. So this is not optional. This is also validating why we can use L'Hopital's rule. Think about it. Last year, if you would have seen this limit, you would have said, well, my goodness, I don't think I can do much algebra to help out. Well, now that we know, though, we have this new method, we've got 0 over 0. And by the way, don't write 0 over 0. Don't even do that, right? Instead, I like to do this. I had a professor who did this, and actually a number of people at the university do this. You won't see the College Board do it, but they'll totally recognize what you're doing. Draw yourself a little cursive L. You're saying, I'm doing L'Hopital's rule. And you can see what I've done. I've checked. These are the important things. You got to check that you can do L'Hopital's rule. Then what? Well, we come over here. What's the derivative of sine? It's cosine of x, right? What's the derivative of 2x? That's 2. I got to say one more clarification, guys. you're not doing the quotient rule. You see that? You're going to take the derivative of the top. That's your new numerator, derivative of the bottom. And we can only do that when we get a 0 over 0 or infinity over infinity. Now what? Well, now it doesn't look so bad. We could say, well, that's cosine of 0 all over 2. Unit circle, well, 0's right here. That's 0.1 comma 0. Final answer, 1 over 2. Look at that. That is a L'Hopital's rule. And it's a total game changer. It can help you out on tons and tons and tons of limits. What do you got to do? Check to make sure you meet those conditions. If you don't meet those conditions, you can't do L'Hopital's rule. Let's take a look at example 2. And by the way, I changed it. Take a look at this. Let's read it together. Very obscure, straight from the College Board. Probably no surprise there, right? Let f be the function defined by f of x equals 2x plus 3e to the negative 5x. And let g be a differentiable function with this derivative. They're not even telling us what g is. Wow. But they are telling us that this limit of g of x is infinity. So they're then saying, following this up, find the value of that limit. So the very first thought is, wow, you can see you're not always going to go to 0. X could go to a targeted c value. It might even go to infinity. Let's just check a few things out. Take a look up here at the top. I'm going to say the limit as x approaches infinity of f of x. Let's check that out. Let's just take a look at that. And very, very, very quickly. Ooh, this is so good. Look at this. 3e to the negative 5x. And you can think, well, my gosh, 2 times something infinite, I think I'm going to get massively big. That's going to infinity. And then we can be a little disappointed. And you could say, oh my gosh, what about this 3e to the negative 5x? Guys, real quick, let me show you something. This is such a great question. Look at the graph of e to the x. Look at the graph of e to the x here. Why am I getting at that? When you look at this numerator, guys, e to the negative 5 times x, when you get something really, really big plugged in, negative 5 times something big, it's as if you've got an e to a negative infinity, right? Negative 5 times an infinity. What's happening as you go to negative infinity? Look at the graph. If you know that shape of e to the x, you'd say, hey, the graph will show me that when I'm going to that negative infinity, e to the x is getting close to 0. That's that horizontal asymptote. So what's going to happen? You can say, well, that's kind of like 2 times something infinite plus a 0. That's just going to go to infinity, right? This thing's going to be going to 0. But they already told you in the given information. I don't know what g of x is, but I can tell you already from that given information, we've got that. So, wow, right now I know L'Hopital's rule will apply. So, tell you what, I'm going to just rewrite this real quick. The limit is x goes to infinity. Maybe I'd write right here by L'Hopital's rule. I'm going to have f prime. What's the derivative of 2x plus 3e to the negative 5x? Well, that's a 2. And then we know that, our e is going to always, that e to the negative 5x, you'll just get the exact same thing. But by the chain rule, a negative 5 will come out. Negative 5 times 3 is negative 15. Look at that. And then down below, g prime, wow, they told us is 1 over x plus 4 cosine of 5 over x. You can see that's what we have right down below. So what did I just do? I had f prime up on top. I've got the g prime down below. Well, we just talked about how to use the graph of e to the x to help us out with this limit. E to something towards a negative infinity, this thing's going to be going to 0. Negative 15 times 0 is, just going to wipe out, and it's just going to be a 2. Down here, 1 over something super big. Remember, 1 over big is small. So if you had like a 1 over infinity, that's going to 0. And 5 divided by something really big, well, that's going to be cosine of 5 divided by something big, that's 0. Well, we just did the cosine of 0. That's 1. So this is a 2 all over 4 times a 1. That's 2 over 4. Once again, that's a 1/2. Okay? So that's a great, trickier question. And it really pulls together some important facts about evaluating some of these e to the power kind of limits. Quite honestly, you want to look at the graph to help you out. Guys, let's take a real quick look at, say, number 3. And sometimes kids will go, oh, hey, I got this. I'm just going to start doing L'Hopital's rule. I'm going to take the derivative of the top, derivative of the bottom, and oh, please don't. Please don't. You got to check the top, right? Does L'Hopital's rule even apply? A lot of times kids will go, oh, listen to the name of this lesson, Mr. Dobner. Of course it applies. Oh, hold on. Look at that. This is 0 plus, well, this is just a 1. Do you see what I'm talking about? E to the 0 power is a 1. I can tell you right now, L'Hopital's rule does not apply. Wow. And down below, of course, as we're looking at this, it really, we wouldn't even have to be checking this out. But look, this bottom is going to be going to 0. The top's going to be going to 1. And really remember what a limit is actually saying. As x approaches 0, down here, this x squared approaches 0. It's getting very small. It's getting tiny. And guys, I got to tell you too, from the right side of 0, you'd be going to 0. You'd also be going there from the left side. Why do I bring that up? Just got to, make a quick point to tell you that when you're dividing 1 divided by something very small, you do want to check directions to make sure that you are in agreement from the left side and the right side. We are. The top's always going to be going to a 1. You can pretty much see that's going to be happening. Down below, you're always going to be having a positive small number. 1 divided by something small is big. See, this is not L'Hopital's rule. If perchance you misapply L'Hopital's rule, you might get an incorrect answer. L'Hopital's rule does not apply, so be careful with that. Okay, last one. Once again, be careful. Check to make sure L'Hopital's rule is even going to be a possibility, right? So I'm going to check my numerator. And you could say, well, x minus sine of x. You could say, well, that's 0 minus 0. It's 0, right? Sine of 0 is 0. You'd say, well, look at the bottom. Yeah, right here, we're going to get 0. And kids will say, hey, that's great. Well, you know what? We're going to do L'Hopital's, okay? L'Hopital's rule applies. The derivative of x is 1. The derivative of sine is cosine. So we get cosine of x. Down below, we'll have 3x squared. And kids will go, okay, well, now I'm going to plug in my 0. And all of a sudden, we're going to feel maybe a little uncomfortable. You'll go, wait a minute. The top is going to go to 0. So will the bottom. Look, as you're looking at this, you'd say, wow, 1 minus the cosine of x. Well, you know what? Cosine of 0 is a 1. That goes to 0. The bottom goes to 0 also. The kids will go, oh my gosh, what do? Do L'Hopital's rule again. By the way, notice what I'm doing. I'm going to continue to write this limit. I'm not going to just skip that over. And, the derivative of 1, hey, that's 0. Derivative of negative cosine, well, the derivative of cosine is negative sine, so negative sign becomes positive sign. Down below, I've got 6x. You'd say, oh, finally. Well, wait a minute. The sine of 0 is 0, and you can check this mentally, but you know what? You'd have to show. Notice what we're doing. We're doing L'Hopital's rule multiple times, but you still have to show you're checking that it applies. You might have to do L'Hopital's rule several times. Look at this. I think you can see already this is going to be our last one. Derivative of sine is cosine. Derivative of 6x is just a 6. And then what? We'd get 1 over 6 because the cosine of 0 is 1. That's all we've got, for this lesson. Don't worry about any additional examples. But what a game changer. We're seeing L'Hopital's rule can be used repeatedly, but you must check to make sure it applies.